Broadcasting live from Tech Square in Atlanta, Georgia, it's time for ATDC Radio, powered by Business RadioX. Now here's your host.
Lee Cantor here, another episode of Atlanta Business Radio, and this is a special one because this is going to be part of our ATDC Radio series. Today we have with us Craig Green with Carbice. Welcome, Craig.
Hi, happy to be here.
Well, before we get too far into things, tell us about Carbice. How are you serving folks?
So Carbice is a thermal materials company. We deliver thermal solutions to all types of companies, really helping them to get the heat out of their electronics and allowing them to really innovate and deliver better products.
So now how did this idea come about?
Sure. So Carbice was founded many years ago, back in 2012, as a sort of a research company by Barack Kohler, our founder and CEO. He's one of the sort of world leading researchers in carbon nanotubes. And he ultimately developed, a platform, that ultimately became Carbice Carbon, as a part of his work as a professor at Georgia Tech. And so I met Barack shortly after the company was founded and kind of worked with him to develop the sort of platform technology into the products that we deliver to market today.
So
that research was funded by folks like DARPA, Intel, IBM, so the leading sort of chip makers in the world, because it was one of the most significant sort of challenges to continuing to innovate at the time.
So now the benefits of removing heat, can you talk about that? Like, why is that so important to companies and why are they so excited about what you got going on?
Well, so fundamentally, heat it's a barrier to innovation. Maybe I'll just give you just a couple of sort of examples to give you a sense of how hot, how much heat your computer or your electronics are generating. So, if you look at some of the sort of high-end electronics devices that are out there, they're generating heat, power density that is on the order of the amount of heat, the power density of the surface of the sun. So a tremendous amount of power is being generated in a very, very small footprint. And the reason why your cell phone's not exploding, your CPU or desktop computer isn't smoking is because of effective cooling. And so there's a tremendous amount of work and research that's gone into figuring out strategies to keep these devices cooler. Because ultimately, if you can't keep those devices cool, you cannot innovate. You cannot build more functionality into those systems because they just get so hot. So maybe just to give you a sense of that. So if we look just at data centers today consume about 70 billion kilowatts of electricity. It just, to give you a sense of how much power that is, that's about 10% of the overall world's electricity consumption, in the next 10 years. And cooling is a tremendous amount of the power that they consume. So of all that sort of billions of kilowatt hours of electricity, about 40% of that just goes into keeping things cool. And so if you can cool more effectively, more efficiently, you lower your overall power consumption, and it allows you to do what you're really trying to do with those different types of technologies. And that's really sort of innovate and deliver value to customers. And we remove that sort of thermal barrier to innovation.
And then with your solution, how did you know kind of you were on the right path? Like I'm sure a lot of people are trying to solve this problem. How did you know that you were onto something? Can you talk about how that kind of, this thing seems to be working. Let's see if we can do more of that.
Well, so fundamentally, our material is built on the carbon nanotube. The carbon nanotube sort of is the end game for thermal materials. It's the highest thermal conductivity material that's going to be produced. And there's been, over the last few decades, really trillions of dollars of sort of research dumped into that technology because it is sort of so promising from a performance perspective. And what really differentiated our material and our technology and what we're doing at Carbice is we figured out how to manufacture it at scale at a reasonable, cost competitive price. Ultimately, it doesn't really matter how good the technology is if it's prohibitively expensive. And so that's what we figured out is we can make this material at low temperature, at low cost, and be able to scale it out such that we can address this tremendous market.
And then can you share the difference, like somebody who's using Carbice and somebody who isn't, the difference in like the temperature? Like what's the kind of how do you measure how effective your thing is compared to either another one or doing nothing?
Well, so, it really kind of depends on the application, but ultimately, like when you look at temperature, even if you're just reducing the temperature of a device by, say, 5 degrees Celsius, that may translate into, an order of magnitude increase in overall reliability of that device. Because essentially the warmer the device is, the higher the temperature it operates at, the sooner it will ultimately fail. Failure is, directly coupled to temperature. And so if you look at, for example, we're starting to look at autonomous driving, which is basically building a computer into your automobile. Well, that automobile needs to last. The typical lifetime of an automobile is 15 years. And so you need to figure out how to ensure that those electronics are able to operate consistently over that entire lifespan to give customers the type of reliability they expect. And so being able to give, 5 degrees, 10 degrees is tremendous in terms of difference in what you can do with an application.
So then what were your first kind of guinea pigs to test this out to know that this was something that was going to work? Was it something like a car or was it, like a phone or a computer?
No. So actually the first market that we really sort of got our feet wet in was semiconductor test. And so that's basically, if you look at the factories that are making your computer processors, each one of those chips are tested in the factory before they're sent out to market. And just like I talked about failure being related to temperature, what they do is they test those devices at elevated temperature and really, really high power so that they fail quickly and they can get rid of those devices. And so what where we first went to market was there, where we essentially took advantage of the fact that we had developed this material that, one, was really, really good at cooling, but was also really, really mechanically robust. And that had been a problem that was very difficult to solve for a long time. How do you put essentially interface material into an application that needs to make and break an interface thousands and thousands or millions of times, as you test chip after chip after chip after chip? And our material was one of the first materials that was really able to sort of survive in that environment.
And then, so once you kind of worked that area, then you found other kind of use cases for it?
Yeah. So, early in our sort of research days, we looked at sort of a very broad variety of applications. And one of the ones that we, sort of early on got our feet wet and kind of looked at was space. And so that's another sector that, we've been going to space for a while, but it's really been growing tremendously recently as, folks like SpaceX and people like that have sort of lowered the cost to get to space. It's become more of a sort of commercial sector. And so you're starting to see some of these large constellations of satellites go into outer space. And so that was another market where for where we were as a business early on, where we sort of had relatively small volume, but we also had a material that we had shown in semiconductor tests was not just a good thermal material, but was also robust in a harsh environment. It was sort of an easy translation to that market that also is a really harsh environment to operate in, that ultimately kind of eliminated some of the other materials that might possibly be evaluated for those applications.
So you tested your products like on the International Space Station?
Absolutely. Our material's been it's spent about a year up on the International Space Station. We sent it up, it's been back. And that was one of our sort of first tests to sort of establish flight heritage for our material. And since then, we've actually been designed into several sort of commercial satellites that are on orbit and operating today.
What was it like kind of doing research with somebody in the space station? Like you were...
Well, so I think the thing that's unique about that market is it's a very conservative market because, I talked about the cost of getting to space being reduced, but ultimately still it costs a tremendous amount of money to send a satellite into orbit. And once it gets up there, if your material fails, you basically have space junk. You can't go up there and fix it and change it out and repair it. So there's a tremendous amount of upfront engineering that goes into really giving customers assurance that the material will perform as expected under a wide variety of sort of conditions that it'll be exposed to, from, the extreme cold of space to the radiation that it'll be exposed to. So it goes through a lot of qualification before you ultimately get that check mark that your material is actually certified to be used.
But once it does get that check mark, it probably shows a lot of credibility to the offering, because if you can do it there, you can do it in a lot of other places.
Absolutely. You get that credibility, and you've also sort of once you sort of emerge from that trial, you have that heritage with you. It's expensive and time consuming to do all of that. And so, that's not something that those customers, that industry does over and over and over again. They do it when they see a good opportunity to do something that's going to be transformative for their business. And once it's done, you've essentially established a beachhead that you can operate in for a long time because you are qualified.
Now, let's talk a little bit about the Georgia Department of Economic Development Center of Innovation, and how did you kind of start working with those folks?
Yeah, so earlier on, as we were kind of building our business, my background is sort of in heat transfer, thermal science, and most of our team has a similar type of background. But I talked about the carbon nanotube and it being sort of a relatively new material to the commercial space. And one of the things that I recognized early on was that we were going to need to talk to the EPA before we started to really manufacture in volume. And, as a small business, it's difficult to both be focused on developing products for your customers and trying to understand how to solve their problems, and to do sort of the background work to sort of develop data and also understand the regulatory process for getting approval from the EPA. And so, I'm a Georgia Tech alum. Most of the folks at Carbice are Georgia Tech alums. And so I was able to sort of hear about the Georgia Centers of Innovation through just relationships I had with folks at Georgia Tech. And so together, we kind of put together a proposal to say, hey, let's sort of leverage the tremendous resource that is Georgia Tech to kind of help us to collect the data that we need to show that our material is safe, and also to help understand what the submission process would look like for a company like us, a new nanomaterials company. And one of the reasons why we really wanted to do it with Georgia Tech is because, at Georgia Tech, not just carbon nanotubes, but nanotechnology research in general is really one of the sort of the areas that, that university differentiates itself. And one of the things that I saw and I wanted to see was really build up a hub of information from our experience, where other companies and other individuals who have good ideas and want to understand how to commercialize their technology can go back and talk to the folks at Georgia Tech and understand, how do I sort of navigate the regulatory process of manufacturing, so that you don't have to sort of reinvent that wheel on your own every time, and just lower the barrier to sort of innovation and entrepreneurship in Georgia.
Now, not only are you involved with that group, you're also involved with the ATDC. How did that come about? Was that just kind of a natural outgrowth? You're already kind of familiar with that ecosystem, and they have so many resources and have had so many successes over the years that it was a logical place to incubate the company?
Yeah, absolutely. It's a logical place to incubate the company, and we sort of grew up through ATDC. So, earlier on, coming out of Georgia Tech, there were programs in place, not just at ATDC, but also sort of through the Georgia Research Alliance, that help to sort of help faculty members to understand how to transition the technology from the lab to a commercial environment. There's so many great ideas that sort of end up getting stuck in the lab because there isn't that interface in place. And so early on, we worked with them to just do the type of sort of proof of principle experiments, data collection, relationship building that we needed to get to the place where we could eventually go to market as a commercial company. And as we did, we kind of graduated through the stages of sort of association with ATDC. And when we were ready to become a commercial entity, we looked at spaces all around the city of Atlanta, but ultimately it made the most sense to stay close to Georgia Tech in the incubator space that is sort of here on or near Georgia Tech's campus, that ATDC provides.
Now, for folks that aren't familiar with ATDC, what would you say is the biggest kind of reason to consider incubating at ATDC? Is it the access to talent? I think that's very attractive.
Yeah, well, it's the access to talent. When I say talent, folks coming out of Georgia Tech, but also it's really the access to expertise. And again, when you're a small business, 2 people, 3 people, you really have expertise in most cases your technical area. But there's so many other areas that are important to building a business. I talked about regulatory things, but I've also, tried to understand how to build a sort of safety culture within our company. And there's someone at ATDC that has that expertise that I can sit down and have a cup of coffee with. Or someone, if there's no one there at ATDC, there's someone whom they can connect me with. And so that building and maintaining that connectivity within the state of Georgia is really what's enabling us to start to build a startup ecosystem. I think, if you think 10 years ago, if you wanted to build a technology business, you kind of, no matter where you came from, you kind of needed to pick up and move it out to Silicon Valley because that ecosystem existed out there. Regardless where the technology came from. And what ATDC is doing is kind of pulling all those things together that already exist in the state of Georgia and helping folks to navigate who those people are, where they are, and how you can work together.
So now how can we help you? What do you need more of?
Ultimately, we're always looking for more talent as we grow. So we're growing today. As I said, we're about 14 now, but we're always looking for bright folks to help us to come and solve problems that we have, technically in our business.
And then what about clients? Or do you have a good kind of base of clients right now, or are you looking for more opportunities maybe in different areas that you're in?
Yeah, we have a very broad pipeline. I think one of the things about Carbice in general and the problem that we're solving is that everyone has it. So early on, the way we sort of did business development was to go to sort of, we had our network, but also I could go and speak at a conference about our technology. And then, at the end of my talk, just kind of go stand in the back of the room and folks would come to me and say, hey, how can I get some of what you have? And so, doing that sort of business development is, I won't say it's easy, but it's something that's very accessible when you're solving a problem that everyone has. But as we grow, I think what I've learned is it's not really just about finding engineers, because typically, I'm an engineer myself. Typically, those folks who I talk to would be other engineers who'd say, hey, I've been trying to solve that problem. But really to get technology adopted into a large company, you need, relationships, not just with those engineers, but with the folks in procurement, with the folks in business development that understand how adopting a new technology affects the broader business and the broader business's bottom line, and having that sort of not just sort of bottom up push of technology into a business, but that top down pull of technology into the business. And so being able to have connections and relationships with folks, with those types of people is always important, and it helps us to be able to continue to be successful in terms of getting our technology actually adopted and integrated into real products.
So if someone's out there that wants to learn more, have more substantive conversation with you or somebody on your team, what's the website?
So www.carbice.com. So CARBICE.com.
Well, thank you so much for sharing your story today. You're doing amazing work, and we appreciate you.
Yep. Thank you.
All right, this is Lee Cantor. We'll see you all next time on Atlanta Business Radio, and especially this ATDC Radio episode.